In semiconductor, the concentration of electrons and holes are 8 into 10 to the power 18 per meter cube and 5 into 10 to the power 18 meter cube respectively. If the mobilities of electrons and hole are 2.3 meter square per volt second and 0.01 meter square volt second, then the semiconductor is. So they have given electron concentration, hole concentration, and also they have given the mobilities of electrons and holes. Now if you observe clearly, number of electrons is 8 into 10 to the power 18 per unit volume, per meter cube, that is. Similarly, number of holes, NH I will write, that is given as 5 into 10 to the power 18 holes per unit volume or per meter cube of volume. Now clearly we can make out number of electrons is more than number of holes. 8, 5 you compare. So the semiconductor is of N type. When holes are majority carriers, such a semiconductor is P type. When electrons are majority carriers, as in this case, then such a semiconductor is N type. That is one type. That is one part of the question answered. N type. Now N type, option A is there, and also option C is given as N type. So you have to calculate its resistivity. So you have to calculate its resistivity, or yes, you have to calculate its resistivity. Now see here, number of electrons, mobility of electrons into electronic charge plus number of holes into mobility of holes into electronic charge will give electrical conductivity. I hope all these things are clear. Electrical conductivity is measured by how mobile the electron is, in terms of conductors. In terms of semiconductors, both electrons as well as holes form current, they contribute to current. So if the mobility of the electrons is more, current will be more. If the mobility of the holes is more, current is obviously more. So electrical conductivity is number of electrons into electronic charge into their mobility plus number of holes into its charge into their mobility. That will give electrical conductivity. Now substituting this is 1.6 into 10 to the power minus 19. Number of electrons is 8 into 10 to the power 18 into mobility of electrons we have to think of. Mobility of electrons is 2.3 per meter square per volt second plus number of electrons, that is over. Now this is number of holes, so that is 5 into 10 to the power 18 into 0.01. Now we have to multiply all these things. 1.6 into 10 to the power 19, 8 into 2.3. So that will come around 230 minus 46 you have to do. That will come around 18.4 into 10 to the power 18 plus this will come around 0.05 into 10 to the power 18. So if this is minus 19, 1.6 into 10 to the power minus 19 into 10 to the power 18, if I take common, then it is 18.4 plus 0.05. So 10 to the power 18 cancels here with this remaining as 10 to the power minus 1. So this is roughly 1.6 into, this is 18.45 into 10 to the power minus 1. Minus 1 is what you are going to get. So the answer of the electrical conductivity is going to be, as you calculate roughly, this is, if I take this as 19, or maybe this is 18.45 into 0.16 you have to do. So that is resistivity, that is electrical conductivity. Now resistivity you have to see. So resistivity is rho is equal to inverse of electrical conductivity. So that will be 1 by 18.45 into 0.16, and that comes around 0.34 ohm meter, which happens to be option A. So the semiconductor is N type and its conductivity is 0.34, rather resistivity is 0.34 ohm meter. Hence option A is the right answer.